basic security. So IPsec was really a bolt-on, an add-on to IPv4. It's something that's part of IPv6. Still has to be configured, still has to be enabled, but you don't need to do the same level of trickery that you did in IPv4 to get it to work. IPv6 also has the notion of roaming IP space. The IP space that's assigned to organizations is so big because the entire address space for IPv6 is massive. One of the ways that people look at it to try to illustrate it is IPv6 has enough IP addresses so that every grain of sand on the earth gets its own IP address. So huge address space. Once we start giving out really large chunks of address space to organizations, to companies, they can use that in a lot of really creative ways. When their roaming users are connected, they can always get the same public IP address. So it makes tracking of users and the accountability and the traceability of user activity quite a bit higher. With the ISP Scale NAT temporary solution, we're going to have all of a sudden ISPs sharing over much bigger areas one IP address. So where we used to have one IP address being one very small location, your home, now it's going to be a bigger location, a city, and it could even be something bigger than that. So it starts to eat away at the edges of the usefulness of geolocation. So ISP scale or carrier scale NAT, network address translation, is really scaling up something that we've always been using at home. At home, we've got one device that connects to the internet. That's a DSL router or a cable router, cable modem, and it has one IP address, public IP address outside that allows it to communicate on the internet. Inside, it communicates to all the devices in your house with private addresses. And what it basically does is does a bit of bookkeeping. It keeps track of who inside is talking to whom and makes sure that all of those traffic flows go the right way. Carrier scale NAT is taking that idea and moving it up in scale. So instead of sharing one IP address in one person's home or in one person's office, one IP address could be shared between thousands of users. It could be a neighborhood or a city or even a province. When IP addresses used to be shared within your home, it was okay, because if one person in somebody's home is doing some malicious activity, it's fair to block that entire home. If it's an entire office, it's a little bit more problematic, but it's still one administrative domain. It's still okay. When you move it up in scale to where you have one IP address being shared, say across a big area of a city, then it's problematic. Then stopping a person on one street from accessing their electronic banking because somebody on the other side of town is doing some malicious activity gets to be problematic. As that causes more and more problems, people are going to be less and less willing to use that very effective tool to block access. So it has a lot of far-reaching security implications. So the problem with large-scale or carrier-scale NAT, network address translation, in a commercial environment really comes down to sharing that IP address. A good example would be, here we are in Paris, in La Défense, in a 30-story building. There could be many, many different companies in this building that end up sharing the same IP address. They don't know anything about each other. They don't know anything about each other's activities. Something that one company does could end up with them being blocked. Their email could be blocked or their web access could be blocked, and that could end up impacting the second company. So leaving yourself open to that also means leaving yourself open to sharing the punishment for somebody else's activity. As a user, as a client of the internet, continuing to use IPv4 means that you're somewhat at risk to that. You're opening yourself up to that effect. If you're behind a large-scale NAT, people often talk about the IPv6 crunch or the dooming problem that's coming in terms of the year 2000. Now, this is going back away from me. I remember the year 2000 because I was working in a banking software company. We built the back-end systems for electronic banking, and we spent a lot of time getting ready for the year 2000. And then, like everybody knows, nothing happened. We'll never know if nothing happened because of all the work people put in, or because there was never really a big problem to start with, and it was all just a scam. And I think people think the same way about IPv6. That's bad, but not terrible. But what's going to happen with the bigger scale ISP carrier scale net is that when they turn off one IP address, 1,000 users aren't going to have access. And that's going to start being a big problem. It's actually quite simple, and what it boils down to is they have an IPv6 native backbone network, something that they've had since '96. I think really the most important thing that NTT bring is the experience. They didn't start doing IPv6 last year or just before IPv6 Day. It's something that's ingrained in their operational methodologies, within their tools. Really, for us at NTT, IPv4 and IPv6 are on an equal footing. So when it comes time to have a hosted site that's serving on the IPv6 network, there are a couple of different ways that it can be done, and we actually have a lot of experience in the migration path, making it very smooth. Specifically this year for IPv6 Day, we did some of our corporate sites. We took corporate sites that were IPv4 only, and we brought up the IPv6 connectivity to them, and without ever interrupting their connectivity to the v4 network, made them available via v6. We did this primarily around the IPv6, the World IPv6 Day event, but since then, we haven't taken it down. So for us, it's not a proof of concept. For us, it was the beginning of the future. We've left things in IPv6, and I really think that most of the sites that we bring up from now on will probably be dual stack. So, unless you have an IPv6 or an IPv4 enabled coffee machine, you probably don't need to worry about the coffee machine. But there are several devices that you might have to worry about. Start closest to the ISP. You're going to have to look at your basic network connectivity, the devices that connect to the network. The ISP is going to help you with this. He's going to make sure that you have the right kind of devices that are IPv6 enabled. Some of your infrastructure, some of your IP infrastructure within your office, whether it's the DHCP devices or the Active Directory, a lot of these things also need to take into account IPv6. The way that you assign IPv6 addresses within the company is going to need to follow your policy that you've got now. So there's going to need to be some work on the IPv6 assigning part of the network. From then on, you get down really to client devices. You can look at your desktops, printers, things like this. Really, it won't be a problem if some of the devices in your office continue to be IPv4 and IPv4 only, because almost all of the client devices, the client workstations, will continue to be dual stack. They're going to be IPv4 and IPv6 connected for the foreseeable future. Luckily, this isn't as terrible as it sounds. Operating systems all the way back to Windows XP are IPv6 enabled and run dual stack out of the box. All you have to do is turn it on. Deep into the backbone network and all the way up to your access router, that's something that NTT is going to take care of, already has taken care of, really, and it's something that they've been doing since 1996. Once we get into your office network, there are things that are going to be easy, and there are things that you're not going to find out until you start using them. Really, the best way to approach this is to set up a proof of concept environment. Once you've got a proof of concept with representation of a few of the different kinds of technologies that you have in your office, that might be different operating systems, different devices, different policy management systems, the way that you dole out your IP addresses. Once you have those replicated in a proof of concept environment with dual stack IPv4, IPv6, you're going to see what works well and what doesn't. Really, from my experience, what I've seen in a lot of different environments, what you're going to find is that many, many, many things already work. You're going to find a few things that don't, and that's where specialists like NTT or some of our partners will come in and help. Really a good thing to do when you've reached the point that you think that you need to enter the IPv6 world, is you need to do a bit of an assessment internally. This is something that hopefully your ISP can help you with. If not, there are a lot of people out there that have the expertise. But the things that you need to do or basic. The first thing, you need to have an ISP that can offer you IPv6 connectivity. You need to find one that has experience doing it in a commercial world, somebody who isn't doing experiments, somebody who's been doing it for quite a long time. And another one of the requirements really from the ISP is they need to be able to offer you a dual stack solution. They need to be able to offer you IPv4 and IPv6 at the same time. Making a big bang switch, jumping from IPv4 and abandoning it and moving to IPv6 isn't the answer, because the IPv4 internet really isn't going to go away in our foreseeable lifetime. There are going to be IPv4 connected devices that we want to access for years and years in the future.